Now, so far the systems we've been solving using elimination have had opposite coefficients, so we were just adding the two equations together. There was that one method that was easiest when we had opposite coefficients. But when you have the same coefficient in front of a variable, there are actually two ways to complete the problem using elimination. So in this example, we have the system 5x plus y equals 17 and negative 2x plus y equals negative 4. So you're still choosing which variable to eliminate. We're still approaching the problem the same way, but you can see that the y in the equations have the same coefficient, and the x's, even though they have opposite signs, they're not opposite terms. You have a positive 5 and a negative 2. So we want to eliminate the y variables, but we're not going to simply just add the equations right away. We actually can add or subtract the two equations depending on how you look at it. The first method would be to actually multiply one equation by negative 1 and then add the equations. Think about it. If you multiply a coefficient by negative 1 and it was the same as the other coefficient, now you've created opposites, which allows you to add the equation. The second method would be to just automatically subtract the equations, but you have to keep in mind that all the signs will change because you're subtracting the signs, or that you're subtracting the coefficients and the terms. So you're taking the opposite of adding. So you just have to remember which one, or think which one will be easiest for you when you approach these problems. Is it easiest just to multiply by negative 1 and add coefficients, or just subtract the coefficients and work with the signs as you go? We'll show that here. So we have our two equations where the first method, we're multiplying the first equation, because remember we had a positive 1 and positive 1 coefficient for y. So if we multiply that first equation by negative 1, that will give us a positive 2x minus 1y equals a positive 4. So now we have the system of 5x plus y equals 17 and 2x minus y equals 4. And we can add those two equations together because 1y now plus negative y will disappear and turn to 0y. And then we'll have 5x plus 2x is 7x, 17 plus 4 is 21, and dividing by 7, we get that x equals 3. Or, instead of multiplying that first equation by negative 1, we're just going to subtract that equation. We'll have 5x plus 1y equals 17 minus negative 2x plus y equals negative 4. You just have to be careful when you're subtracting, because here we have to think this is 5x minus negative 2x, and minus a negative is really adding 2x, so you have to do 5x plus 2x equals 7x. Then you'll have your 1 minus 1, which is 0. That still eliminates. So you're still achieving the same goal. And then you have 17 minus negative 4, which is really 17 plus 4, so that's 21. So I guess the only disadvantage of the second method is you're often subtracting negative numbers, which can be confusing for sometimes. You just have to keep it straight that you're really adding or doing the opposite of what the sign of that number is. So we still end up with those 7x equals 21, and if we divide by 7, in both cases we get x equals 3. Right? Why would these methods produce the same solution? How is multiplying by negative 1 and adding the same thing as subtracting? Well, think about it. Both methods produce the same solution because, like I just said, multiplying by negative 1 and then adding is the same as subtracting. So we are able to do that. We're able to choose which one we're more comfortable with. Then once we have the x value, it goes right back to normal elimination step number 3. Since we have one of the variables values, we have to plug that or substitute that into one of the equations to solve for the y value. So we'll use negative 2 times x plus y equals negative 4. Substituting in x equals 3, we end up with y equals 2 to get our solution of x comma y is 3 comma 2. And if we perform our check, we get true statement, so that is really our solution. So just be careful when using elimination and your system has the same coefficients of a variable you're trying to eliminate. You have a choice. You can multiply one equation by negative 1 and add the equations, or you can just subtract the two equations.